Hello, can you hear me? Okay, so hello. I would like to welcome you at my presentation. It's regarding the Kubernetes cluster that is production grade. There is a clickbait in 6 months because production cluster is in production state for longer than 6 months, and probably you will start serving production traffic well before the 6 month period ends. So Bartek took first slide out of me, so let me introduce myself once again. The important part, I love rocket science, so you would have some references in our presentation. The rest is as Bartek said. So what do we mean by having production grade cluster? So for many of us, production grade cluster of Kubernetes would look quite different. So there is a funny story where we were creating a custom Kubernetes cluster for a very big client, and we spent like 6 or 8 months doing that, hardening it, getting people the right access, securing it, etc., etc. So they were starting with everything in place, starting from logging and monitoring. We even deployed the default application for them, so the developers can start using that cluster since day one. And then the AWS EKS came along, and some people from our company started that cluster with the user interface from AWS, and they went to the directors, and they said, yeah, they are doing a cluster for 6 months, and I've done it for within 5 minutes. So that was quickly debunked, because obviously that wasn't even close to what we were providing. So I was really getting into how to get the production cluster, and I was thinking, what did we do to get there, and how did we do it? So the we came to me, the we word came to me a lot of times. So I've decided that the first slide would be that we, the people, is the most important part of getting your production cluster ready. So without a proper team, you would not be able to have any production cluster at all, because you need people that are capable to do that are capable to deliver whatever they are told to do, and they need to think about it. Our team consists of very different people, but together we are like fulfilling each other. So there is one of the ex-developers, the one that is 10 times better. Well, that's my opinion. There is there is a hacker which will deliver everything and always on time, no matter at what the costs. And there are the rest of us that do just the things that we are told to do. And there is the quote, you know, I love rocket science, so I couldn't leave that without Elon Musk. There's that quote that people are mistaken when they think that technology just automatically improves. It does not automatically improve. It only improves if a lot of people work very hard to make it better, and actually that will. So without good team, you are not getting the production cluster done. And now let's go to the second important part, as I think. So service level agreement or service level objectives. As a developer, cloud engineer, for me the first one is not that important as the second one, because we are agreed to deliver the working product. The first part, the service level agreement, is only for our management. Service level objectives really defines what we are building and how we are doing it. Without that, you cannot start making your production cluster or any cluster at all, because you need to have some knowledge about it. You need to know what you're going to do. So high availability is defined by the SLO. It says how long it's available, what's the throughput, frequency, and the response time on the on traffic served by the cluster, and its quality. So even if you're there is a common mistake made by the management that they tell you to deliver, for example, cluster that's uptime is like 99.9999, and that's not even possible. Well, it is possible if you do that in an internal network. You have your power plant, and there is no outgoing traffic to the internet. There is no way someone can guarantee you that amount of uptime. That's only up to you how that will end up. But don't let yourself be fooled, and don't let yourself be targeted to goals that are not even possible to be done. You can optimize things forever and always, but they will never be there. So it's like catching something that you cannot catch at all. And the SLA key points are quite different. So what services to be provided, times, location, costs, performance. So that's what the management is talking to each other, and that's how they see our cluster, but that's not what you should focus on delivering. High availability for the Kubernetes cluster, that's the bare minimum. Not sure if you were yesterday at the Elasticache talk. There was that question, how many nodes, master nodes, do you need to have high availability? So there is a 3, because you need to have a quorum. But from our perspective and our knowledge, that 3 is not enough, because you need to be ready to update. And what happens if you're updating and there is a catastrophic failure in the cluster? So the bare minimum for us is a 5. That's what I think production grade cluster has to have. So I will explain later on how to differentiate clusters where you have almost exactly same cluster on the development environment that you have on production environment, but they are different in some ways. Your workloads needs to be defined on worker nodes, so you cannot use your masters as a platform for your pods that are doing some production traffic. Best part is to have it multi-zone, and if possible, multi-region. And and often people forget about the etc.d. So it's like, yeah, we have highly available cluster, and when we ask, okay, so what's your backup strategy for etc.d? The most common answer is there is no backup for etc.d. So it's like, yeah, you're highly available at some level, but at the top you're not. And some information about network architecture. Most common, it's like, it's a must, is to have overlay network in a Kubernetes that lets you abstract networking, lets you have multiple layers and create virtual connections. So as for overlay networks, there is many providers of that. We have AWS, that's VPC CNI. There is a Flannel, that's the default networking overlay network. Flannel is most common because it's very easy to set up, but it's not that fast. So if you're going to for the speed and for robustness, you would go for Calico. there was that network plugin that was called Canal, but it's debunked right now because when they were working on that, it was connection of Flannel Calico, but during the work on creating that canal, they came to conclusion that there is no need to do that because one and another can be adjusted, so the Calico and Flannel can do that both right now. There is the Google Cloud networking plugin for the Google Kubernetes cluster, Google provided Kubernetes cluster. There is also the Weave from Weave Networks. That one is the most robust, but that comes with some difficulties with the configuration. There are also other projects like Romana, etc., but I did never have any time to really deeply look at it. So we have integration strategy. The first thing when you first thing, that's one of the things you have to do when you're building your cluster is to make sure that you have your IP address management in place. It depends on the organization you are working, but if you're working in a big organization, which consists of many layers of services they provide, they usually have big networking. And if you're not careful enough, you can end up in a state where you are already generating production traffic, and there comes someone to you that you need to integrate with another service, and it only then came to you that your IP address clashes. So IP access management is a very important stuff since day one. Okay, let's do the secret management, both for cluster and the infrastructure. So you have you have a lot of options that are good and bad, that are fast, and that you need to spend some time setting that up. You have, for example, the Helm as a secret management. You have the AWS secret management, which you can plug into your Kubernetes. But what we came to is the simplest and, well, in our opinion, is the simplest way to do that. So we store all our secrets in a Git. That came out of necessity. So we wanted to track everything that we have deployed on cluster and when that was changed. So we wrote a tool which enables you to encrypt and decrypt secrets just in time. So when your credentials are set to AWS and you have your access assigned to decrypt those secrets, you can decrypt them by rendering them directly to the files that you're going to deploy. So first step we do is encrypt secrets with the, for example, KMS. The application currently supports free cloud providers. There's the AWS, Google, and Azure. I'm going to use AWS as an example here. So we encrypt that with KMS, and then encrypted form ends up in a configs or directly in a desired manifest or CloudFormation stack or whatever. And then when we want to use it, we have that render tool, which we are using. We are abusing that to in every possible way. So that render tool will be able to render your secrets. So it will use your access to decrypt the secrets for you and place them in files. So the decrypted secrets are always in a git ignore, so we don't commit them by mistake, and the encrypted secrets are always in Git. So we track their change in time, etc., and who changed what, etc., etc. And yeah, basically that's the key point of the encryption and decryption. So we store that in Git. Now, So the next step for the production grade cluster is the autoscaling, stability of work and isolation. So if you're starting your cluster and your cluster is going to serve production traffic, you cannot do that without resource quotes. It's like worst idea ever. That will kick you in the first thing that will bring you some errors while you're serving production traffic will be because you're missing of that one. Then you have your pod security policy to tell who can do what, and your network policy, which pods can communicate with each other. So for autoscaling, autoscaling is a fun functionality provided by Kubernetes. You can use that, for example, with AWS. You have your autoscaling group, which will add more nodes as you need them during your working hours. So, for example, when there is a Christmas time, often the traffic is much bigger, so your autoscaling group will kick in and add some nodes. Small digression here, so do not do that like without limits, because you might end up waking up one day and find someone is mining bitcoins out of your cluster, and when you do not lock your autoscaling group, that can be really, really costly. So autoscaling kicks in when it's needed, and that helps you also save your costs. So when your cluster is not doing the hard work, it can reassign pods to different nodes and tear down some of the worker nodes. As for observability, I would go with the audit logs first. You cannot imagine how often people ask, where can I find some information who changed what on my cluster? And without that, it's not possible. I've seen some questions about, we've done something to cluster 2 months ago, and how we can find out what was that, because since then everything is breaking up, and without audit logs it's hard. And second thing for observability is configuration as code for me. So when you store everything in a Git, you will know what changes have been done to your cluster in the first place. For storing logs, there are 3 major players on the market. There is the Elastic Stack. That's the most common one because you can have that for free. That's the Elasticsearch for gathering the logs. Logstash for forwarding them, and Kibana to visualize them. You can use that as well for the monitoring. You have Splunk. We were heavily using Splunk. It is good in some ways and very bad in many others. But the way we were doing that, we had managed Splunk clusters, and we were forwarding logs to them via Fluent plugin from each node. And then the Splunk created their own way to forward logs to Splunk from the Kubernetes. They have universal forwarder, which is mostly common used now, the heavy forwarder, which is installed on every node, and the light forwarder, which right now is obsolete because everyone moved to universal forwarder. And there is a Datadog. The Datadog is, for me, the most exciting logging platform. Well, that comes at the cost. So your production grade cluster is really easier if you have money, and you can do and move a lot of stuff out of your bags to the providers. There is monitoring. For monitoring, there are 3 major players: Prometheus, Influx, and Grafana. I had pleasure to use only those 2, the Prometheus and Influx. And out of that, you're creating your Grafana reports. And from that, there is an easy way to have your alerting. So when you have your graphs when you have your monitoring on your cluster, it's very easy to have alerting in place. With the alerting, oh man, time's going really fast. So with the alerting, you should have at least 3 levels of alerting. The one that you have to look within few days, the one that you need to look within hours, and the one that you need to look right now. So bear that in mind. And the deployment strategy. As for deployment strategy, we use configuration as code. We abuse that very strongly. We abuse template mechanisms. So every and each of our cluster is coming out of one common template. And if we need to create another cluster within, we can have it configured and build up within few minutes, only by rendering it with another configuration that lets us to easily have easily testable Kubernetes cluster that lets us see the history. The configuration as code lets us to see the history of change, and we always commit to the Git currently running version of Kubernetes and infrastructure code. There are some things that you can use and that can help you with deployments, like Helm. My personal opinion, do not use Helm 2. They came up with the Helm 3, which is much better and much nicer than the previous one. Do all you can to not use Helm 2. And if you're using Helm, try to use Helm template. If not possible, don't use the umbrella charts. So try to use your try to deploy only one chart with Helm. Do not do that interdependent of itself. And there is the Jenkins operator. That's the thing that's saving us a lot of time right now. So we move the care and share of the Jenkins to developers. So we just provide them operator and say to them, hey, if you want your Jenkins, configure it for yourself. It will be working on your Kubernetes. Currently, we are running like 5 of them on our cluster. 5 Jenkinses. And next story, managed versus custom. So if you have money, go for managed. That's my personal opinion. If you don't, go with the custom. So there should be one more screen. There is the hardest way of getting the Kubernetes cluster is getting Kubernetes cluster the hard way from Kelsey Hightower. And there is that COPS, which is well used, but I'm not buying the idea of it. It supports AWS right now, and there is a Google Cloud and DigitalOcean in the beta. There is a Typhoon. Typhoon comes out of the Tectonic guys. So Tectonic was the project was killed, and one of the developers took the good lesson out of it and created the Typhoon. I'm surprised that it's running in. It's able to run Kubernetes 16.1, I think, 1.16 right now. It's like up-to-date custom cluster tool. It allows you to deploy on AWS, in beta on Google Cloud and Azure, and also alpha is the bare metal. And there is the Rancher. If you have money, you can go for Rancher. Rancher will provide you custom Kubernetes clusters as well as the managed Kubernetes clusters. I don't find any value in providing managed Kubernetes cluster by Rancher, but that's my personal opinion. And there are managed clusters. Those are the most common players on the market. So that's Amazon EKS, Azure AKS, and Google Cloud Engine, Kubernetes Engine. And the Rancher, because it can deploy that on all of those cloud providers. And the incident management. So when you have your traffic on a production and your Kubernetes is up and running, you want to have a support assigned to that Kubernetes cluster, because when something goes terribly wrong, you have to have some people that will answer to that issue. There is the support team. You need to manage your support team the way that you have the most the best developers, best operations, with some that are not that good, so they can interchange and they can learn from each other. You need to propagate your knowledge. There, you need to have assigned the type of support you are providing, schedule, and the ways you communicate. There should be an email and at least some of the mobile phone communication for that. So when there's an incident, you have your team assigned, and there are many of incidents that can happen. That can be the one that's are very severe. Then you can respond right now, because, for example, your company can lose literally millions within few minutes, and you want to have your team up and run up for that to fix that. And you need to have the mechanism to escalate to the second supporter. So if the first one do not respond in a given time, you just propagate it to another, and if not, try to escalate it higher. That's have to be time dependent. And after that, after you fix the issue, do not forget about creating postmortem. And support tickets, the last one. When users of your cluster need some help from you, you have to have some way of them to communicate with yourself. Do not be fooled to use Slack or any other ways of communication other than tickets, because they will not let you live for a long time. They will ask you questions all day long. And yeah, I think that's it, because my time is out. So, any questions?
Yeah, we run out of time, so maybe let's give a try with one question. So maybe the first one. What's your thought on Loki plus Grafana for logging purposes?
I have no opinion. Sorry, I'm not able to know every technology that is out there on the market, so I don't know Loki at all.
Okay, what about the second one? Is Elk Stack well suited for storing large amount of logs, 10 hundreds of gigs? Have you tried that?
Coming back to the first question, I can do some research for you, and I'll be happy to answer to your questions. As for the second one, we have guy from the Elastic cache, Elasticsearch here, so I think that's the best person to ask that question, and you'll get the best answer for that. Any other questions?
I think we are out of time, so feel free to continue this interesting conversation after the talk. So thank you, Maciej, for your presentation.
So if you want to talk, if you want to have some discussion, I'll be at the Virtus Lab place down there. So if you want to know more or you're interested in some additional info, let me know. Thank you very much.
Thank you again. The next